Triangle inequality theorem. Theorem 1. If two sides of the triangle are not congruent, then the angles opposite them are not congruent, and the larger angle is opposite the longer side. So we don't know the measure of BC, but we do know that AB equals 35, and we know that AC equals 45. So from here, I can tell you that AC is going to be larger than AB. But let's talk about this part of the theorem. AC has the angle B that's opposite to AC. So you can say that B is going to be a large angle. And then I have line segment AC, and the angle opposite to that is going to be C. So while I don't know the measurements of angle B or angle C, I do know that I can now assume that angle B is going to be greater than angle C because 45, or the side opposite it, is larger than the other side, which is AC. The second part of the theorem, if two angles of a triangle are not congruent, then the opposite sides of them are not congruent, and the lingering side is opposite the larger angle. So this is basically looking at the same type of theorem, but just looking at the angle measures only, and then talking about which side would be the longest side. So again, none of these are congruent, so I know that angle A equals 110, angle B equals 46, and angle B is 24, and angle C equals 46. So now I'm going to say angle A is larger than angle C, which is larger than angle B. We also need to identify the opposite sides. So BC goes with angle A. Let's try a different color. BC goes with angle A. Angle C goes with side AB. And angle B goes with side AC. So if I had to take these sides and put them in order from greatest to smallest, I would say that I have BC is larger than AB, which is larger than AC. Okay, so for the first example, it says to look for the longest segment in the figure, so we're looking for the longest side. So to find the longest side, we also need to find the largest angle. Okay, so let's see. 77 is the largest angle, and the side opposite of 77 is going to be segment VD. So the longest segment is going to be VD. Okay, in B, it says write the measure of the triangle, and then angles in order from least to greatest. Okay, so that means that we're going to take all the angles. All right, so UV, the opposite angle is going to be L. Then for LW, the opposite angle is going to be U. And then for LU, the opposite angle is going to be W. So let's see. I know that UV equals 7, LU equals 10, and LW equals 12. So write the measure of the triangle. We did that. And then angles in order from least to greatest. Okay, so let's accentuate the angles. So these are my angles. That means since 7 is the smallest size, I'm going to have angle L is less than, and the next size is going to be from W is less than W, which is less than angle U, because U is opposite the longest length. Let's write that again. So I know that L is less than W, which is less than U for the angles. And that's your solution. Okay, write the measure of the triangle and then angles in order from least to greatest. So that means that we're going to have to look at these two triangles that are put together. So what's unique about this quadrilateral is that this angle H can be split into two. So 35 is going to be H1, and then 48 is going to be H2. So as we put these together from least to greatest, that's all we're going to do. So write the measure of the triangle. I believe that wants us to match the sides. I'm going to start with the smallest angle. So angle Y goes to HK, angle H1 goes to KY, angle Q goes to, oh, I'm sorry. Angle Q goes to HY, and then I have angle H2 goes to QY, and angle K, which is the largest, and this is a very specific angle, this goes to side HQ. So we're going to go from least to greatest. It's going to be angle Y is less than H1, which is less than Q, which is less than H2, and then less than K. And then if we had to do the sides or the segments, we would say that HK is less than KY. And then you would say that you have less than HY, which is less than QY, which is less than HQ. Okay, so now we have the triangle inequality theorem. The sum of two lengths of any two sides of a triangle is greater than the length of the third side. All it is an inequality. So what you're going to need to know is that triangle XYZ has three different sides, and if we add two sides of that triangle, for a triangle to be true, the sum of those two sides needs to be larger than the third side. So here we go. So in this case, we need to write out all the different inequalities. So I'm going to say that I have x, y, plus xz is going to be greater than yz. And then I'm going to say x, y, plus yz is going to be greater than xz, and then yz plus xz is going to be greater than xy. Okay, next it says examples D. They have 3 different examples. Which set can be the lengths of the sides of a triangle? Remember, the inequality has to be true. So if I have lengths 3, 6, and 9, you have to order them, and you have to say you're going to add these two. So 3 plus 6, and let's see, and the last side is 9. So 3 plus 6 is 9, so 9 equals 9. So in this case, this is not a triangle. The sum would have to be greater than. Okay, and the next one, 2, 3, and 8. So I'm going to add sides 2 and 3. So 2 plus 3 and 8. So 5 and 8. 5 is less than 8. So again, this is not a triangle. And then if we look at a triangle with sides 6, 6, and 8, so 6 plus 6 is going to be 12 is greater than 8. So this is true. And so you're going to say this is a triangle. Alrighty. Okay, so for example E, F, and G, I'm going to ask you to find or estimate a third side. So let's see. E says find the possible side lengths of 2 sides of a triangle are 5 and 9. So here's what you need to know. This is called a compound inequality, which means that you are going to have 2 sides to your inequality. So I'm going to say A minus B is going to be less than X, but that also has to be less than A plus B. Okay, so here we go. We're going to say that A equals 5 and B equals 9. So 5 minus 9 is less than X, which is less than 5 plus 9. And we're looking for the absolute value. So that means that anything that comes out of the absolute value is going to be positive. So I get absolute of negative 4 is going to be less than X, which is less than the absolute of 14. So if I take it out of the absolute value, 4 is less than X plus 14. Excuse me, X is less than 14. So our length of our possible third side is between 4 and 14 for the triangle to be true. Okay, so example F, if 2 sides of the triangle have length 8 and 10, describe the possible lengths of the third side. So we're going to use the same compound inequality over here. So we're going to say absolute value of A minus B is less than X, less than the absolute value of A plus B. And I know that A equals 8. It doesn't matter what A and B are. B equals 10. So absolute of 8 minus 10 less than X less than the absolute of 8 plus 10 is going to be absolute negative 2 less than X less than 18. So I have 2 is less than X less than 18. So this is the possible measurement of X has to be between 2 and 18. Okay, and the last one is asking us to solve the inequality for X. Okay, that's pretty easy. So now we're going to say, okay, so let's suppose it says solve the inequality for AB. So AB equals 6x minus 11, and AC equals 2x plus 3, and BC equals 3x minus 1. All right, so let's put this in order. So from here, I'm going to say, look at the inequality one more time. I'm going to add A, B, and BC. So 6x minus 11 plus 2x plus 3 is going to be greater than 3x minus 1, and they want us to solve for x. So I have 8x minus 8 is greater than 3x minus 1. I'm going to collect like terms and subtract 3x from both sides. So then I get 5x minus 8 is less than negative 1. Add 8 to both sides. I have 5x is less than 7. Divide both sides by 5. And then from here, I say that x is greater than 7/5. All right, see you in class.